Let's discuss this representation of the periodic table. You'll see that there's some dark lines outlining some larger boxes, and in general chemistry we will learn to recognize that this is going to be the S box, the D box, P, and the F box. But for this current course, we're most concerned with identifying an element as either a metal or a nonmetal. You note that there's these green boxes that correspond to metalloids, but metalloids are not going to be important to an intro chemistry course. What is centrally important is that recognizing if you have an element that's a metal, it's somewhere in the yellow region, when it forms an ion, it's going to lose electrons, lose one electron or more electrons. That leaves it with a positive charge. We call these type of ions cations. Nonmetals, these in the upper right-hand corner, gain electrons when they form ions, and these negatively charged ions are called anions. Let's talk about predicting the charge on an ion when it forms. Predicting the charge on transition metals, those that are outlined in green here, is well beyond the scope of this course, and we're not going to worry about it here. What we are going to be worried about is predicting the charge on the representative elements, those elements that are inside these boxes outlined in red. When we consider the representative elements, we have numbers on top of each of these columns, 1 through 8. Now, some textbooks label these slightly different. On your periodic table, these are labeled 1A through 8A. These numbers tell us the number of valence electrons, those electrons that are in the outermost shell, for elements within this column. Once we know the number of valence electrons, we can apply the octet rule to predict ionic charge. The octet rule is that atoms tend to ionize or combine such that they achieve 8 valence electrons. And this would be the same electronic configuration as the nearest noble gas. For example, iodine has 7 valence electrons. It can accept an additional E. Therefore, it has 1 extra electron, 1 electron greater than the number of protons, so the charge is a -1 charge, and we represent the iodine ion as I-. Calcium and other elements in 2A have 2 valence electrons outside of a shell of 8. So if they lose 2 of the valence electrons, they have that remaining outside shell of 8, and therefore they complete an octet. Calcium and other 2A elements have 2 valence electrons outside of a shell of 8. So if they lose 2 electrons, they go back to the shell of 8. That's how they complete the octet rule. Now they have 2 less electrons than they have protons, so they have a +2 charge, and we can represent the calcium ion as Ca2+. Oxygen, 6A, 6 valence electrons. To get to 8, it can accept 2. It has 2 more electrons, 2 additional negative charges, so the overall charge on the ion is -2. The oxide ion is represented by O-2. Okay, note here that if the charge is either +1 or in this case -1, that number is not needed. Aluminum, 3A, has 3 valence electrons. It loses all 3 to go to the shell beneath that contains 8 electrons. We have Al3+ as the resulting ion. Potassium, 1A, loses its single electron to go to that outside shell of 8, so it has an octet now, and the potassium ion is K+. 2 remaining columns of the representative elements, 8A and 4A. 8A elements already have 8 valence electrons. They have a complete octet. They're happy. They typically don't form ions. Carbon can and does either lose 4 or gain 4, but that's very unusual. So in this course, we don't typically deal with ions of carbon.